3 sum. Interesting. I know what you're thinking. Anyways, let's get started. All right, let's go. Given an array S of n integers, are the elements a, b, c in S such that a plus b plus c is 0? Find all unique triplets in the array which gives the sum of 0. The solution set must not contain duplicate triplets. For example, given an array as we have -1, 0, 1, 2, and -1 and -4. And as we can see, -1 and 0 and 1 is one solution. So there we go. And then we have -1 and -1 and 2. So there's only one unique solution for a -1. So there's no -1 to -1. So now this is one thing we need to take note of. The solution set must not contain duplicate triplets. Okay, so how are we going to do this? Now, the naive way, which is similar to what we did last time, is to brute force, right? Same as to sum. We're going to start from, okay, let me open up this common section. Oh, no Chinese. Right, so we have -1, 0, 1, 2, and -1 and -4. So on the top of my head right now is that we can do a brute force solution for every single number. We will start from every single number, all right? Not every single number of the subset. So for -1, the subset is 0. Now, the subset is 0, 1, 2, -1, -4. So we're going to start from 0, 1, 2, -1, and -4. And then from there, we're going to start from 0, and the subset of 0 is 1, 2, -1, and -4. So from -1, we will have to find if there's any sum of two numbers. If there's any two numbers, a pair of numbers whose sum is in 1, right? And for 0, we need to find a -1, right? So we're gonna go through this and see if there is any -1. So we got -1, and then so we have -1. So for here, we're looking for 1. Now I think I'll just write down the answer. So we have -1, 0, and 1. And same thing for 0. So for 0, the subset will be 1. Well, actually, we are not done yet. So for 1, we have the subset is 2, -1, and -4. So 1, we need, since we have -1 already, so the next one, the sum of the next pair of numbers, we need it to be 1. So we have 1 already, which is not what we want. Okay, so we're going to move on to the next one. 2, obviously, well, we have -1 and -4. So -1, what we want is the sum. We want these two. We want the sum of these two to be 1, well, which is impossible because we need. Well, actually, yes. Actually, yes. So we have -1, and then we want the next pair of numbers to be the sum of the next pair of numbers to be 1. So we have 2 now. So we need a -1, which is here. So now we have -1, 2, and -1. So vice versa. So it's pretty straightforward. We're going to have 3 for loops to iterate through this, but is this the best solution? Now, what's the time complexity? So the time complexity here is big over n, because, well, not big over n, is n to the power of 3, so n cubed. No, because for every single number you have to go through its subset, and for every single number of the subset you have to go through a subset of the remainder again. So it's 3 for loops, which is n cubed. Now, the good side of this, you see, not everything is bad. You know, everything has the goods and bads, right? Just like when you're dating, you know, you have this dramas going on, but sometimes you have these sweet moments when you're dating. Anyways, space is so I wasted 10 seconds to talk about bullshit. Okay, so now, so the space complexity is, of course, we don't need to use extra space. So, is this the best solution we can come up with now? We can boil down. So previously we did a question. We did a episode on 2-sum, right? So the 2-sum, we are trying to look for a pair of numbers whose sum is equal to a target number. So this is very similar to 3-sum, except we're going to use the solution for 2-sum as a kind of like API. So, and the time complexity for 2-sum is linear time. So if we can do use 2-sum technique to well, not exactly, because I think we have to use a method called 2 pointers, I think. So we can sort it first. So first of all, okay, this is the line, new line. Okay, so first of all, we will sort it first, and then for every number, we'll do a 2-sum of the subset. Now, since it's sorted, we can use a 2-pointer method. So we can have a starting pointer at the beginning, and a end pointer at the end. And if the sum of this new number is smaller, then which means we may want the number to be bigger, so we'll move the head forward. Or if the sum is smaller, then we want, if the sum is bigger than the target, then we will move the tail to the center. So okay, without further ado, let's get started. So first of all, we need to sort this. Let me make sure I have enough time to code this up. So first of all, the time complexity is now first of all, we need to sort the array. So it is n log n plus the time that we use to get the result, so which is for every single character, we will do a two-sum calculation. So it's 2n squared, which is equal to n squared. Now, the space, which happens to be the same as our naive solution, is constant space. So wow, perfect. Now, let's get started. So we're gonna sort this numbers array, and then now I think we need to create a list to store the results. So we're gonna have list integer, and the results is unless new linked list. We're gonna have linked list and list integer. Okay, so for every number, we're going to start from I is 0, I is less than numbers dot length. So I plus plus. Now, first of all, we need to pay attention to this. It must not contain duplicate triplets. So either if the current number, if I is equal to 0, or numbers I is not equal to numbers I minus 1. So what this means is it either has to be the first number of the array, which makes sense because like it doesn't have any, it doesn't have a identical number before this number, so it's because it's first one. And the second condition is that we don't want to calculate the same. We don't want to calculate. We don't want to calculate the same solution twice for the same number, right? Okay, so now this is good, and then we will have to get tail. So we're going to have a head is going to be I plus 1. Well, actually, this is, I was wrong. So this should be minus 3. So, for example, if the length is, let's say if the length is 4, we want it to stop at, so it's 0. So if a length is 4, we're going to have 0, 1, 2, 3. So we want it to stop at 1, all right? So 4 minus 3 is 1, okay? So we want it to be -2. Okay, so alright, so we have a head, and then we have tail, which is numbers dot length minus 1, and then hold on, let me make sure that this is nice. Okay, yeah, this is good. Okay, so now the target number is, so the sum is 0, right? Okay, so the target number is the sum of, you know what? Let's do this. Let's do sum is equal to numbers head plus numbers tail. Okay, so and we're gonna have target is going to be 0, minus the current numbers. Okay. So if target is equal to sum, which is perfect, which is what we want, right? So first of all, we will add okay, now while head is, first of all, this is a while loop, so that we can move the head pointer and the tail pointer to the center. So while head is less than tail, because we can't guarantee that there will be a solution. So once head and tail is equal, then we'll get out of the for loop, the while loop, sorry. So if sum is equal to target. So if sum is equal to target, which is exactly what we want, so we will, of course, we'll return it. So we will create a linked list. Molly? Who's... Someone just texted me. Anyways, so we have a linked list, and then this list will put in our current number, and it will put in our head, and we'll put our tail. Okay. Alright. So let me see. We're going to add the current number, we add the head, we add the tail, and right now what's missing is we're going to add this list to results. So one more thing, we can't have duplicates. So while numbers head, well, first of all, we need to make sure that head is less than tail, and head minus 1 is equal to numbers head. We will increase head, and same thing, pretty much the same thing except it's tail. So while head is less than tail, and numbers tail plus 1. Well, I somehow feel like it should be tail minus 1 and head a plus 1. Okay, yeah, because tail is at the end. If you plus 1, it's gonna overflow. So equal to numbers tail. And then tail minus minus. Oh, let me check if I have time. 9 minutes. All right. So once we get out of where they're not equal, once head and tail is not equal, we need to also because this is head plus 1, so we also need to increase head by 1 and tail decrease by 1. So I think that's about it. Else if sum is less than target, then what do? So sum is less than target, so we want the sum to be bigger next time, right? So we want the sum to be bigger next time, so we will increase head, else we will decrease tail, which means sum is larger, so we want this sum to be smaller next time. And then I think we should move sum into here and target into here. Okay, I think that's pretty much it. And at the end, we will return result. Okay. So let me see if I have time. Okay, 7 minutes. We can go through the test case together. All right. So now, let's see. So we have this number, and then we'll sort it. It becomes -1, -1, -4, -1, -1, 0, 1, and 2. And then we're going to start from 4, -4. So 2 pointers will start from -1 and -2. So we'll have head is I plus 1, which is this one, and tail is the end of the array. Okay, so the sum is is 1 right now, and the target, which is 0 minus the current number, is 4. So we want to be 4. The target number is 4. Okay, so now 4, now -1 plus 2 is 1. 1 less than 4, which is ahead, it will need to increase. So all the way increase to the end, but it's 3, so there's nothing that is equal to 4. That's sad. Now, okay, we're going to move on to the next number. And we have -1. So -1, so -1 is, we'll have -1, and the head is -1 here. So the head is -1, and tail is number length -1, 2. Okay, so now the sum, let me make sure I have enough time. So the sum is head and tail for now. So okay, anyways, so we need the target number. So the target number, 0 minus -1 is 1. So we want next pair of numbers to be, the sum of next pair of numbers to be 1. All right, so we got So we're going to start from -1 and 2. Okay, that's perfect. So sum is equal to target. Now we're going to add -1 and -1 and 2. Okay. So, and while this is not equal, right? So head plus 1 is not equal to this, and 2 minus 1 is not 2. The position of 2 minus 1 is not equal. So we'll break out of the while loop, and then at the same time, -1 move forward to 0, 2 move forward to 1, and that we got lucky again. The sum is 1 again. So we will have -1 and -1 and it's -1 and 0 and 1. Okay. So after that, head plus plus, head minus minus, head and tail equal. Okay, so I think we're good. So let me run the code and see how it goes. Okay, looks pretty good. All right, let's put it to the test. Oh, I've been passed. Okay. Okay, accepted. Perfect. Okay, cool. All right, so this is a very straightforward. Solution. So for any sum problems, right? For any sum, 2 sum, 3 sum, 4 sum, 5 sum. Wow, this sounds like, hey, 5 sum. Anyways, you can start from you can start from 2 sum, and then after you solve 2 sum, you can use the solution to solve 3 sum. So 2 sum has usually, for me, I think it's usually 2 methods. One is hash map, which is similar to the one that I did in the previous episode, and the second is to use 2 pointers. All right, sort the array, and then start from the beginning, and the other pointer start from the end, and then move towards the center while we compare the target and the sum of the 2 pointers. All right, that's it. Well, thanks for watching, and see you next time. Happy coding.